In the vast observable universe, it is estimated that there are approximately 2 trillion galaxies. Each galaxy contains anywhere from a few billion to 100 trillion stars. Of those countless galaxies, the Milky Way is one of them. The Milky Way galaxy contains around 400 billion stars. Of those billions of stars, our Sun is just a small star. Like in most other solar systems, planets orbit around the Sun. The perfect distance from the Sun and other special features make one planet different from other planets. That planet is called Earth. On that planet, around 8 billion unique creatures are living. They are called humans. Of all those unique creatures, you are one of them who is thinking about how all things were formed. So how did all these fantastically large things come about? Where did they come from? Since everything is made up of atoms, then how was the first atom created? In 1922, Edwin Hubble was making some observations on distant galaxies with his telescope. He found something strange. Galaxies are not stationary entities. They are moving away from us and from each other. Although some scientists had ideas and theoretical concepts about galaxies moving, Hubble provided the first confirmation that the universe is expanding uniformly in all directions. The universe was born 13.8 billion years ago. As time passes, the universe expands and cools down. If we reverse time, everything shrinks, getting hotter and denser. Ultimately, everything will converge into a tiny point at zero time. This is the idea for the Big Bang Theory. In later years, this theory was proven in many ways, such as by the discovery of the cosmic microwave background image. Now let's go to time zero. At this time, the Big Bang had not yet happened. All energies were packed into a zero volume, or singularity point. If we travel back before time zero, we can identify what caused the Big Bang. However, we truly don't know how this tiny point emerged from nothingness. So it's better to skip the event before the Big Bang, otherwise it will take up too much of our thinking. To understand singularity, we first need to know about Planck length and Planck time. The Planck length is the smallest possible length that exists in our universe. Below this length, classical ideas about space, time, and gravity become invalid. The length is 1.6 into 10 to the power of minus 35 meters, or 100 quintillion times smaller than a proton. The Planck time is the time required for light to travel a distance of 1 Planck length in a vacuum, which is a time interval of approximately 5.39 into 10 to the power of minus 44 seconds. Planck temperature is about 100 million degrees Celsius, or 10 to the power of 32 Kelvin. Our Sun's temperature is 5700 Kelvin. Planck values are beyond human comprehension. Anything below the Planck length becomes impossible to create calculations for. So the time between zero to Planck time is considered as the Planck era. At this time, all four forces, gravity, the strong nuclear force, the weak nuclear force, the electromagnetic force, were combined into a single superforce. If we want to understand this, imagine the different phases of water. It can be ice, water, or vapor, which are all aspects of the same thing. But at a certain temperature and pressure, all these things can exist in a single phase. However, it's not the correct way to envision the Planck era, because this era is related to quantum phenomena which featured an unimaginable temperature, density, size, and energy. Even though this time duration was part of the Big Bang, the actual bang happened after the Planck era. Between the incredibly short timeline of 10 to the power of minus 44 to 10 to the power of minus 36 seconds, one major event took place, the Grand Unification Era. At this time, immeasurable energies were packed into the tiny volume that began to overcome the Planck limit. At the beginning of this era, gravitational force separated from other forces and gave the first real meaning and existence to our universe. At the end of this era, the size of space was sufficient to produce quarks, antiquarks, and gluons from energies. However, these were massless. So there was no theoretical difference between particle and energy. They were all the same. At the end of the Grand Unification Era, the strong force successfully began to separate from the unified force. Scientists believe this force separation process sparked cosmic inflation. The greatest inflation happened between the timeline of 10 to the power of minus 36 to 10 to the power of minus 32 seconds, and the universe expanded in size at least 10 to the power of 26 times. This means it grew by 100 million billion times within this tiny fraction of time. This expansion occurred much faster than even the speed of light. Cosmic inflation occurred faster than the speed of light. However, it didn't violate any principles of our universe. There is a law that the speed of information cannot exceed the speed of light, but there is no law or speed limit for how fast the medium, space, can expand. So space itself expanded too quickly, faster than the speed of light. Thus, cosmic inflation intentionally happened to destroy information about what came before. After this inflation, the temperature dropped to about 10 to the power of 18 Kelvin, but we don't know how far the universe expanded. Now the time is 10 to the power of minus 12 seconds, but still electromagnetic and weak force are not separated, combined together, called the electroweak force. The temperature of the universe at this stage is more than 10 to the power of 15 Kelvin, and there are no ordinary particles yet, just massless particles, gluons, and pure energy. So here, quarks and gluons existing together make up what we call quark-gluon plasma, or quark soup. But at the time of 10 to the power of minus 10 seconds, the temperature dropped below 10 to the power of 15 Kelvin, causing the electromagnetic and weak forces to separate. This separation of the weak force leads to massless particle gaining mass. The initial matter particles formed. At this stage, other elementary particles, such as electrons, have already begun to form. The particle era has started. When the particle era began, both matter particles, quarks and antiquarks, were formed in equal numbers, and constantly annihilated each other to become pure energy again. But fortunately, the universe created slightly more matter particles than antimatter particles. That means for every billion antiquarks created, there are 1 billion and 1 quarks created. Electrons and anti-electrons are also created in a similar process. So this imbalance between matter and antimatter creation leads to the real creation of our universe. If they were formed in equal numbers, the particles would eventually annihilate each other, and only energy would be left. No quarks, no electrons, no atoms. As time passes, the universe continues to expand and cool down. At 10 to the power of minus 5 seconds, the universe around 1 trillion Kelvin, the quark-gluon plasma began to form into protons and neutrons. Now the universe is 1 second old, and the temperature has dropped below 10 billion Kelvin. Almost all matter and antimatter particles have annihilated each other. The great fight between matter and antimatter comes to an end. As we already saw from the imbalance of antimatter creation, some matter particles were left. Thus, the remaining protons, neutrons, and electrons finally survived. This may seem like a long process, but everything happened within a second. Just 1 second after the Big Bang, protons, neutrons, and electrons formed. These are the building blocks of atoms and everything else. Now it's 3 minutes after the Big Bang. Our baby universe has begun to step up for the first time. Protons and neutrons come together to form the first nucleus. The universe is still too hot, so electrons aren't able to capture the nuclei. Electrons freely move through the hot universe. But free neutrons aren't as stable as protons. They decay very quickly, in 17 minutes, and become protons. However, when they are together with another neutron or proton, they become stable. However, most of the neutrons decay into protons, and that's why our universe has more protons than neutrons. 87% protons and 13% neutrons. Remarkably, some neutrons manage to bond with adjacent protons before they could decay, resulting in the 13% neutrons left. 20 minutes after the Big Bang, the neutron decay process comes to an end. Now the nuclei of hydrogen and helium have formed. The imbalance of protons and neutrons means the universe has more hydrogen atoms than helium, because helium nuclei requires 2 neutrons, while hydrogen nuclei requires only 1 proton, or 1 proton and 1 neutron. So at the end of these 20 minutes, the nuclei ratio looked like 75% hydrogen and 25% helium. So now all atoms are ionized. That means the atoms are positively charged. To become neutral, it's necessary for atoms to capture electrons. If a negatively charged electron binds with a positively charged nucleus, it becomes a completely neutral atom. But the universe is still hot enough, so electrons aren't allowed to orbit nuclei. When electrons try to orbit nuclei, the temperature doesn't allow it, and they're thrown away. However, the universe continues to expand and cool down. Now that the universe is 380,000 years old, it has reached a temperature of 3,000 Kelvin. This temperature allows electrons to orbit the nuclei. The electromagnetic force was enough to bind nuclei and electrons at this temperature. Finally, 380,000 years of hard work has won a major prize. The first stable atoms formed, constituting the start of the era of recombination. Not only the electrons were struggling, but also the photons. Photons means light. When stable atoms formed, the photons were captured by nuclei, and the electron clouds were finally freed after 380,000 years. The high-energy photons traveled through the universe. The first light of the universe was exposed, and the universe began to become transparent. Today, we can still see that the first light appeared 380,000 years ago, thanks to the cosmic microwave background image. Though they have lost energy over time, we can still detect them today in the form of the cosmic microwave background radiation. So finally, the first atoms were formed. 100 million years after the Big Bang, the first stars started to emerge from the hydrogen gas clouds. We already know that because of the immense amount of pressure at the core of stars, hydrogen atoms fuse into helium and then into other heavy elements like oxygen, carbon, and iron. Iron atoms are extremely stable, so the star's pressure is not enough to further the fusion process. Thus, the star dies and explodes as a supernova. This supernova event spreads heavy elements throughout the universe. 9.5 billion years after the Big Bang, our solar system was formed. Then, after 10.5 billion years, somehow, the first life formed on Earth as a single-cell organism. As time flowed, the most complex evolutionary process took shape. Finally, 13.8 billion years after the Big Bang, the most unique creatures yet discovered appeared in the universe. The humans, who are the only creatures capable of analyzing, calculating, and bearing witness to the existence of the universe. If we are the only unique, intelligent, conscious creatures in the entire universe who are able to understand the existence of the universe, then the universe itself waited for us for 13.8 billion years?